Hi guys, happy Halloween. We are nearing the end of the week here, so we're going to get into Newton's second law today. Title says third laws, but we will wait and do third laws next class. So we're going to be talking about acceleration in terms of mass and force, and then be able to calculate the direction and magnitude of the resultant forces that were caused, or the resultant acceleration, I should say. So Newton's second law is a law of motion. It is specifically talking about the acceleration of an object that is caused by a force. So the acceleration of an object that is caused by a force is directly proportional to the magnitude of that force and inversely proportional to the mass of the object. So if you look on the left-hand side here, we have some formulas. This first part here, this little alpha, is representing a proportion. So acceleration is proportional to force, acceleration is inversely proportional to mass, and then we get this very basic formula here for acceleration. And let that little menu go back down there for a second. So acceleration is always measured in meters per second squared. Force is measured in newtons, and mass is kilograms. So if you remember, the actual derived unit for force is kilograms times meters per second squared. We just call it a Newton because Newton is kind of the person that's given credit for coming up with these ideas, and it's shorter than writing all that out. So that being said, anytime we're making our calculations, acceleration needs to be in meters per second squared, and mass has to be in kilograms. So if you look on the right-hand side, we have the kind of the classic force formula is mass times acceleration. So that's the net force of whatever's happening in that situation. So if we look at the top box, we have an average size box with a greater force. So that's going to give you an acceleration and generally higher acceleration. So let's say you have the same box, the same size mass with less force, it will give you a lower acceleration. And then if you have a large mass with the same amount of force, you would have the lowest amount of acceleration. And then the end here, you have a small box with a medium-sized amount of force would be the highest amount of acceleration. You could argue that the first and the last one would be pretty close because of the size difference in both the mass and force. But the idea being that if you have a very large mass, you would need more force to cause the same acceleration. So the net force is what we are looking for in most of these, at least to get started. So you will find the net force of all of the forces acting on the object. And then once you find that, you could figure out the acceleration if that's what's being asked for. So we can use kinematics formulas since we are drawing force diagrams, and force diagrams are vectors. So there's a lot of the same skills we've been using already this year. So you will find the x and y components separately, and then create a new, or you could say that you're adding the components. So a new vector diagram using the calculated force of x and force of y, find the resultant vector for that, and calculate the angle. So I'm going to show you a bunch of examples of these to kind of walk you through some problems. And one other thing, and this was kind of addressed in the assignment from last class, that objects with a net force of 0 are in equilibrium. That doesn't mean that there are no forces. So you can still have an object with many forces being acting upon it, but if they all balance each other out, it is in equilibrium. So first example, very simple example, is you have a 5.7 kilogram wooden crate, experiences a net force of 6.1 newtons west, determine the crate's acceleration. So we have this basic acceleration formula of force divided by mass. So in this case, we have the force of 6.1 newtons west divided by the mass of 5.7 kilograms. So the overall acceleration of the crate will be 1.07 meters per second squared west. You do have to have the magnitude, which is the number value, the unit, and the direction. Since these are all vectors, they all have units and directions. Another example is this picture here on the left. So you have a raft that is floating on the surface of the water. There's going to be an upward buoyant force, which is equal to the force of gravity. And we know that the force of gravity is 1,225 newtons downward. So there's a force of 150 newtons east from the winds and 215 newtons east from the current. We need to find both the net force and the acceleration. So we're going to find the net force first. So if you look at this picture or the diagram here, we have the box and we're drawing the force vectors away from the box here. So at the bottom you have Fg, which is your force of gravity, or the weight of the object will be 1,225 newtons. The problem told us that the buoyant force was opposing the force of gravity equally. So at the top you have Fb for buoyant force at 1,225 newtons. Then we have two eastward forces. We have the force of the wind, which is Fw at 150 newtons, and then the force of the current, which is Fc at 215 newtons. So we're going to figure out what these are separately and then compare them. So if we look at the first portion here, we have the net force of X would be anything on the X axis. So in this case, they're both moving in the same direction, so you're adding them. But if you have them in opposing directions, you would subtract them to find the difference. So here we're going to have 150 newtons east plus 215 newtons east gives us a total force, a net X force of 365 newtons east. For Y, you have an equal force up and down, so you're going to have a zero net force on your Y axis. So that makes things simple for us. Since the F net for Y is zero, the only net force we have at all will be horizontal force. So to find the acceleration, now we are going to plug in, we're going to substitute in our net force, which happens to be 365 newtons east, divided by the mass of 125 kilograms to give us the net force of 365 newtons east, and the acceleration of the raft will be at 2.92 meter per second squared east. Next example, the number of these are out of order. So this is example 3. Here's our Halloween example. You have a killer clown, a serial killer clown. So you and two others are trying to help contain the clown until the police arrive by using 3 ropes. So you and 2 of your friends have lassoed this clown, and you're trying to pull it in 3 different directions so that he cannot move. So your first friend is exerting a force of 30 newtons to the south. The second friend is exerting a force of 40 newtons to the east. What angle and with how much force should you pull on your rope so that the net force acting on the clown is equal to 0 and he can't move? So what we need to do here is we need to find the resultant of the forces that we know. We need to find the resultant force of that. So we'll calculate that, and then you will find the angle. But then we have to flip that around backwards to the opposite direction because that would cancel those 2 out, right? So if we have the resultant force of that, it should be equal but opposite to say what the third rope would have to be at. So first we're going to find the resultant force vector. You use Pythagorean theorem. So you should have your side of 30 and 40 and have a resultant force of 40 newtons. And then we have to figure out what direction that would be in. So we would just determine the angle using some trig functions here and determine that it would be 36.8 degrees south of east. So if you were pulling in the same direction as your friends, you would be pulling it south of east, but you're not. So at the very bottom here, where it's written in red, this is the important part, that you're providing the opposing force. So where should you be standing, and with how much force should you be applying to balance your friends out? So we know this, we just have to flip our information around. So we know that we have to be applying a force of 50 newtons, and the angle and direction has to be opposite. So you would be applying it at 36.8 degrees north of west instead of south of east. Last one here, example 3, we have, I'm going to put all this up. We have a person that got his truck stuck in a muddy field. You and 2 others are trying to help pull out his truck using 3 ropes. So your first friend has a force of 500 newtons to the north. Second is 800 newtons to the east, and you are pulling with a force of 600 newtons at 40 degrees south of east. What total force are you 3 applying, and what direction will the truck move? So if you look at the diagram that's drawn here, the truck is just in here. We don't have an upward force. This is north, east, and then like our southeast here. So if we're looking at this as a coordinate plane, north would be 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. So if we're looking at that in that context, we're going to use some of a combination here of our trig functions and our net force calculations to solve for the net force for x and for y. So for the net force for x, we're going to use sine as our trig function here. So you would have the force, the first magnitude of the first force, sine angle of the first force, plus the magnitude sine angle of the second, plus the third, plus the fourth, and so on, however many you would have. So in this case, we have the first force had a magnitude of 500 newtons, straight up northward. So straight up here would be 0 in our coordinate plane. So 500 sine 0 plus 800 sine 90, because the next one was over here at 90 degrees, plus 600 sine 130. Okay, so pay attention to that part because it says it's 40 degrees south of east. So if we measure 40 degrees south of east, if you're starting at 0 going all the way down to this, that would be 130 degrees. So what we should figure out is that we have a net force in the x direction of 1,259.6 newtons. We're going to do the same thing for y, except we're going to switch our trig function to cosine because we're trying to find the parallel force instead of the perpendicular force. Or sorry, we're finding the perpendicular force instead of the parallel force. So here, we're going to use the same idea. You have the force, the magnitude of the force, cosine angle for each of the forces involved. So we would have 500 cosine 0, 800 cosine 90, and then 600 cosine 130. So then we end up with a total vertical or total y force of 114.3 newtons. So then we have our net F and net force X and net force Y. So we're going to find the resultant vector of those. So you would again use Pythagorean theorem down at the bottom here where it says resultant vector. So we would plug those in. So we have side Y, you can substitute that in for A. Side X, you can substitute that in for B. Solve that to find your hypotenuse or your resultant vector, and it should be 1,264.7 newtons. So now we have the magnitude of the force, and we need to find the angle. So in this case, you would come in, you find your angle, you'd use your tangent function and rework that to solve for the angle. So you're going to be plugging in the y and the x values that you calculated as your net forces to find the angle. So this is a very small angle in this one. So your final answer for this is that you are all applying 1,264.7 newtons of force, and the truck will move in the direction of 5.2 degrees north of east. Okay, so here's some formulas you guys will use for the assignment today. The assignment is obviously on Canvas, and you have a couple of vocab-related questions and like thought answers. You have a couple of more simple net force questions, and then you have 2 questions, the last 2 pages. You're going to have to use some of these formulas to solve. So just make sure that you're taking it step by step. You first have to determine the net force in the x direction and then the y direction, then find the resultant vector of that information and go from there. So you will use some combination of all of these formulas on your assignment for today. So give it a shot. Let me know what you think, and I will be uploading a key to last class homework today sometime. So the free body diagram practice, I'm going to put that on today's agenda so you can review that if you haven't yet turned that in or had any questions asked. So give it a shot. Let me know if you need any help, and I will talk to you guys next time.